In this second part of exploring trigonometric functions of any angle, we will look at how symmetry looks like when we are discussing rotation on the circle. So assume that we have an angle theta in standard position. Initial side is on the positive x-axis, and the terminal side is in quadrant 1 for easiness of just doing the math, because quadrant 1 has the property that everything is positive. What happens when we are looking at the angle pi minus theta? So pi minus theta will be an angle that is 180 degrees, and then I will back up theta. So the reference angle is still theta. It's just that this angle is in quadrant 2. And if I have a random point P with coordinates A, comma B in quadrant 1, then when I sketch the triangle, A will be the horizontal distance from the origin to where the leg of the triangle ends, and B will be the vertical distance that I sketched. And this R will be the square root of A squared plus B squared. So when I am in quadrant 2 and I have the symmetric point of this P over here, and let's call it P prime, what will this new X be and what will this Y be? And if you can see the symmetry, these two triangles are congruent, which means they have the same lengths for the hypotenuse. So the hypotenuse would be the same R. The Y will be as equal to B, and because Y is in quadrant 2, then it will be positive B. And X will be equal to A, but X is in quadrant 2, so it will be negative, but equal to A. So the coordinates of this point P prime will be negative A with B. And therefore, if the sine of theta was Y over R, which is B divided by R, then the sine of pi minus theta will be Y over R, which is B divided by R, and they will be the same. If the cosine of theta is X divided by R, which in our case is A divided by R, the cosine of pi minus theta will be negative A divided by R. So the cosine of theta and the cosine of pi minus theta have opposite signs, but same absolute value. The tangent of theta would be Y over X, B over A in quadrant 1. In quadrant 2, Y over X will be B over negative A. So they will be opposite. The cosecant of theta, the secant of theta, and the cotangent of theta are the reciprocal of the sine, cosine, and tangent. So we will observe same properties with the sine, cosine, and tangent if we were using the formulas to find those. But in this example here, we don't have to. Now, what does pi plus theta look like? That's P3 primes. So pi plus theta is your angle theta plus 180 degrees from there. So it is the extension of the terminal side of theta, but now I'm in quadrant 3. So in quadrant 3, that symmetric point, the P with 3 primes, and again, if I draw the right triangle that's attached to the x-axis, the reference angle is equal to theta. And I have some y coordinate, which is equal to b, but in quadrant 3, it will be negative b, because b in quadrant 1 is positive. And I have an x coordinate that is equal to a, but in quadrant 3, it will be negative a. So that point will have coordinates negative a and a negative b. And therefore, when I'm trying to find the cosine, the sine, and the tangent of that point, it will be negative b over r, the opposite of the sine of the angle theta in quadrant 1. Cosine of pi plus theta will be negative a over r, opposite of the reference angle theta. The tangent will be negative b over negative a, which is b over a, and it will equal to the tangent of the reference angle. If I have the angle negative theta, how would that look like? Well, theta is in quadrant, let's make it blue. Theta is in quadrant 1, therefore negative theta will be a symmetric angle in quadrant 4. So I will have this point, the symmetric point to P. I'm going to draw the triangle that attaches to the x-axis. The r will still be the same. The y coordinate will be equal to b, but in quadrant 4 it will be negative, and the x coordinate will be equal to a, and in quadrant 4 it is positive. So the coordinates of this point P double prime is a negative b. Therefore, when I'm trying to find the sine of negative theta, so I'm here in the last column, the sine of negative theta will be y over r, so that's a b, negative b over r, so it will be opposite of the reference angle in quadrant 1. The cosine, it will be x over r, it will be exactly the same with the reference angle in quadrant 1, and the tangent will be y over x. Negative b over a will be the opposite of the tangent of the reference angle from quadrant 1. 2 pi plus theta is a location on the circle where I actually travel 360 degrees and then I add theta to myself. So to my rotation. Therefore, I'm right where theta was. So 2 pi plus theta and theta are coterminal. So coterminal with theta. I'm in the same point. So I'm still in the point A comma B if I'm looking for the symmetric. Therefore, my trigonometric functions are identical to each other. I'm still in the same point A comma B. So that will be B divided by R, which is the sine of theta. A divided by R for the cosine, which is the cosine of theta, and B divided by A, which is the tangent of theta. So we want to be able to sketch the angle in the correct quadrant, create a triangle that contains the reference angle, and figure out the correct signs to know the trigonometric functions of the angle in the quadrant we are in. And before we go to the last part of our notes, I want to go to homework 3.3 question 8 that discusses exactly this. So we have an angle T, and for easiness, we will assume that T is in quadrant 1, that is T. And we will pick a point P on the terminal side that has coordinates A and B. And I will attach I will create the right triangle that attaches to the x-axis. A is the x-coordinate, B is the y-coordinate, and R will be the square root of a squared plus b squared. Now we want to look at the angle P minus T. Where is pi minus T? Pi minus T is in quadrant 2 because I do pi, which is 180 degrees, and then I go back T. So this is now T over here. And we want to know what are the coordinates of the point P that is symmetric to my original P. So when P comes here, what are its coordinates? What is the X and what is the Y? So the two triangles are congruent. The X has to be related to A and the Y has to be related to B. So they have to equal to each other except maybe for their signs. So the Y will be B, but the X will be negative A because A is positive in quadrant 1 and it will be negative in quadrant 2. Where is negative T? Negative T is in quadrant 4. So that point P is now here. I want to know what is the X. I want to know what's the Y. And again, the X will be identical to A and the Y will be identical to B or corresponding to those, except maybe for the sign. So X is A because in quadrant 4, we have the same X with quadrant 1. And B, the Y will be negative B because the length B in quadrant 4 is negative. Now we want to go to our next one. So actually, let me just redo the drawing. I'm again here. This is my T. For easiness, it's in quadrant 1. This is my point P, A comma B. When I sketch this triangle, A is the X and B is the Y. So if I have the angle pi plus T, where is that? It is at T plus pi. Pi is 180 degrees. Or at pi plus T, so go to 180 degrees and then advance by T. So I'm here. And I want to know what is this X equal to and what is this Y equal to. And again, the triangles are congruent. So this reference angle is equal to T. Therefore, the opposite will still be B. The adjacent will still be A, except maybe for the signs. Now, A and B are positive in quadrant 1, but A and B will be negative in quadrant 3. So the X will be negative A and the B will be negative B. The final point is at 2 pi plus T. 2 pi plus T means that we have done a full circle and then we advanced by T. Therefore, this location is 2 pi plus T rotation, and the coordinates will be identical to the point because we are falling on ourselves. So A and B. I hope this was a little helpful. So if you can figure this out here, there are certain angles or certain rotations of a particular point on the terminal side of an angle theta that result in identical cosine and sine. So the last part of our notes is asking us if we can find a different angle within the same circle that has the same sine with 230 degrees and the same cosine with 230 degrees. So where is 230? 230 is an angle between 180 and 270, so it's somewhere here. So it's this way. And if I pick a random point at the end of it, it will have some x and some y that are both negative. So if I want the same sine with 230 degrees, I need the same y, and the same y is reflected about the y-axis, so it will be here. So I need this to be the same y, and the x will be positive now. So the question is, what angle is that? And from 180 degrees to 230 degrees, which is this angle, the difference, the reference angle, is 50 degrees. And therefore, this reference angle will be 50 degrees. I cannot say that the angle is negative 50, because negative 50 is not an angle from 0 to 360. So I need to have an angle from 0 to 360. That angle is 360 degrees minus 50 degrees. Therefore, the angle is 310 degrees. They have the same reference angle and they have equal y's. So the one angle is in quadrant 3 and the other angle is in quadrant 4. Now, to find the angle that has the same cosine, I need an angle that has the same x. Now, to have the same x, I need to be in quadrant 2. So I have to be symmetric about the x-axis. So these guys have the same x. They also have the same reference angle, 50 degrees as well. Therefore, the angle I'm looking for that has the same cosine needs to have the same reference angle and needs to have the same x. It has to be in quadrant 2. 180 degrees minus 50 degrees, the answer will be 130 degrees. So 310 degrees has the same sine with 230, and 130 degrees has the same cosine with 230. Let's check in our calculator to make sure we are correct. So I'm going to say, what is the sine of 230? And it is some irrational number, and I get a decimal approximation. What is the sine of 310? Remember to keep your calculator in degree mode, and it gives me the same value. It is negative, and it looks like it has the same decimal approximation. What's the cosine of 230? Again, I get this decimal approximation. What is the cosine of 130? And the answer is the same. So I think I figured it out correctly. Now, same idea here. I have 40 degrees this time. 40 degrees is in quadrant 1. That's nice because 40 degrees has all trigonometric functions positive. If I pick the endpoint or the point on the terminal side, then the same sign will be the symmetric about the y-axis. So it will be here. The reference angle in quadrant 2 will be 40 degrees. So I'm talking about 180 minus 40 degrees, which will be 140 degrees. And the same cosine will have the same x. So I will have an angle in quadrant 4 with the same reference angle of 40 degrees. So it will be 360 degrees minus 40 degrees. 320 degrees. And again, I can use my calculator just to double check that the two irrational numbers have the same decimal approximation, including the sign. This concludes our review of trigonometric functions of every angle.